In this problem, I will be calculating a rate conversion using a formula and dimensional analysis. We are told that 1,000 mLs of D5 1/2 NS is ordered to infuse over 18 hours, and we have IV tubing with a calibration of 12 drops per milliliter. At what rate in drops per minute should we infuse this bag of D5 1/2 NS? Now, I'm going to first start with the formula approach. As we know, the formula here, if we have the total number of milliliters that needs to be infused, we know the ratio of drops per milliliter of the set, and we know the time in minutes, then we can plug them into this formula here, and we would have our rate in drops per minute. It turns out I am given each one of these pieces of information. I know in this problem that the volume that needs to be infused is 1,000 milliliters. I know the volume is 1,000 milliliters. The drop factor is going to be the ratio of drops per mLs. And in this problem, I know that every single drop is made up of 12, or excuse me, every single milliliter is made up of 12 drops. That is provided to me right here. This is going to be different, potentially different, for each problem that you see. But in this problem, our tubing takes each milliliter and breaks that into 12 drops. The time needs to be inserted in the denominator. I am told the infusion time in this problem, up here, 18 hours. If you plug 18 in as the denominator, it will be wrong. What we need to do is to first convert 18 hours into minutes. And I can do that by multiplying it by 60. So if I take 18 hours and I multiply that by 60, then I will get the total number of minutes that I need. So 18 times 60, you get 1,080. So that means this infusion would take place over 1,080 minutes. I can now plug this into this formula, so I'll have 1,000 times 12, and what's happening there is I'm finding the total number of drops that's in this IV bag, taking the milliliters and turning them into drops, and then I am going to be splitting that amongst 1,080 minutes. So what I would get is 12,000 up in the numerator, 12,000, and when you divide that by 1,080, you're going to get 11.1 repeating. And we know if we're talking about drops per minute, which we are, we're going to round this to the nearest whole number. So this would be 11 drops per minute. The tricky part with this is just remembering that you need to convert the time in the denominator into a unit of minutes. So if it's given to you, if the infusion time is in hours, you need to convert that to minutes. Using a dimensional analysis approach, we can start with any rate that we want. And in this problem, I know that 1,000 mLs it would be infused over 18 hours. So I can start with that rate. I know the volume to be infused is 1,000. The infusion time is 18 hours. I know at the end of my dimensional analysis, when I am completed, or when the problem is completed, I need drops in the numerator and I need minutes in the denominator. The easiest step to do is to be able to cancel out hours using a conversion factor from hours into minutes. I know the ratio of hours into minutes. So by writing hours in a unit of hours in the numerator, converting that to a unit of minutes in the denominator, I have now, just with this one conversion factor, I would have found the number of milliliters per minute if I were to stop here. But I don't want milliliters per minute. I want to cancel out milliliters. So I'm going to cancel out milliliters by writing a unit of milliliters in the denominator of my next factor. And I want to go from milliliters to drops. Well, this is going to be the calibration. This is going to be the size of the tubing here, which we know is 12 drops every 1 milliliter. So 12 drops every 1 milliliter. We now see up top we're going to get that same 12,000. If we were to multiply all the numerators there, in the denominator we're going to get that 1,080. This is the same ratio that we got previously, which we found to be 11.1 repeating. which we can round to the nearest whole number, 11 drops per minute. Both of these approaches allow us to get our solution of 11 drops per minute.